Okay, so we're going to look at converting from decimal to binary. And we'll work with a number, we'll say 235. And if I'd like to convert decimal 235 to binary, the first thing I should do is write out my binary places, which are 1, 2, 4, 8, 16. Notice the pattern, 32, 64, 128, and we'll go one past the 235 is 256. Next thing I look is, can I subtract 256 from 235? No. Can I subtract 128 from 235? The answer to that is yes. So I put a 1 in the 128's place. There's one 128 in 235. And then I need to know how much is left. Well, the result of subtracting 128 from 235 is 107. So I don't have 235 anymore. I have 107. I really could write this anywhere or even do it in my head. I like writing it down so that I could keep track. Can I subtract 64 from 107? Yes, I can. There's 164 in 107. So I subtract, and then I have 43 left. I'm going to write down the 43, and I will cross out my 107. The next thing I do is see, can I subtract 32 from 43? I can, so I put a 1 in the 32 place, and what do I have left over? 11. Can I subtract 16 from 11? No, I cannot, so I put 0. I have 0 16s in 11. Can I subtract 8 from 11? Yes, I have an 8 in my 11. Now I have 3 left. Can I subtract 4 from 3? No. Can I subtract 2 from 3? Yes. So I put a 1 in the 2's place. I cross out the 3. I have 1 left. Can I subtract 1 from 1? Yes. So I put a 1 in the 1's place, and this is my result right here. That's my binary representation of 235. So now we're going to try binary to decimal. And we'll use the binary that we just had, which was 0, 1, 1, 1, 0, 1, 0, 1, 1. So to convert this, I'm going to do the same thing. I'm going to write out my binary places, 1, 2, 4, 8, 16, 32, 64, 128, 256. So I have a 1 in the 1, I have a 1 in the 2, I have a 0 in the 4, I have a 1 in the 8, I have a 0 in the 16, I have a 1 in the 32, a 1 in the 64, a 1 in the 128, and I don't have any 256s. So now all I have to do is anywhere that I have a 1, basically that bit is on, and I will add it. So I'm going to have 128, 64, 32, 8, 2, and 1. So 8 and 4 is 12, and 2 is 14, and 8 is 22, and 2 is 24, and 1 is 25. So I put down my 5 and carry a 2. 2 plus 2 is 4, plus 6 is 10, plus 3 is 13. So I write down my 3, carry a 1, and I have 235. Note that is the same number I had previously. Next we'll see how we convert binary to hex. So let's try converting binary to hex. And so we'll use the same binary I just had, 0, 1, 1, 1, 0, 1, 0, 1, 1. So to convert from binary to hex, we really just need to change our binary so that we distinguish sets of 4, which we said 8 bits is a byte, 4 bits is a nibble. So we're working with a nibble. There's a leading so let's look at this. We don't need the leading zeros, so let's work with 1, 1, 1, 0, and then 1, 0, 1, 1. So to convert this to hex, all I need to do is see what is it that we have here on the right. What is that equal to in decimal? And that we have a 1 in the 8ths. And change the pen. We have 8, 4, 2, 1, right? 1, 2, 4, 8. So we have 8 and 2 is 10 and 1 is 11. And then if we look at this set over here, we have a 1 in the 8, a 1 in the 4, and a 1 in the 2. So 8 and 4 is 12, and 2 is 14. And so these are decimal, right? We'll write that 14 decimal, 11 decimal. Well, what's 11 decimal in hex? Remember, for hex we have 0 to 9 and then A to F. So the number 11 in hex is going to be B, and the number 14 in hex is going to be E. So if we convert binary to hex, the binary for 0, 1, 1, 1, 0, 1, 0, 1, 1 is EB. So, and I'm going to leave off the leading 0. So 1, 0, 1, 1 binary equals so 1, 1, 1, 0, 1, 0, 1, 1 binary equals EB hex. So now we're going to take a look at hex to binary. And we'll work with the E, B, and hex. So E is equal to 14 decimal, and B is equal to 11 decimal. We need that in binary. Remember, for binary we only need to work with a nibble, 4 bits. So we have 1, 2, 4, 8. To get 11, we start from the left and we say, okay, we have 1, 8, no 4s, 1, 2, 1, 1. 8 plus 2 plus 1 is 11. And then for the 14, we need an 8, a 4, a 2, and no 1s. So to convert, we'll work from left to right with our numbers. We have the equivalent of an E is 1, 1, 1, 0, and then the equivalent of the B is 1, 0, 1, 1, which is what we saw in the previous set of numbers in the last page. This is also equal to decimal 235. So we see if we need to go from decimal to hex, we can go from decimal to binary and binary to hex. And if we need to go from hex to decimal, we can go from hex to binary and binary to decimal. So in this case, working with hex to binary, now that I have the binary, we can go full circle and see we have a 1 in the ones, a 1 in the twos, a 1 in the 8. No, 0 in the 16, a 1 in the 32, 1 in the 64, and 1 in the 128. If we add this all together, 128, 64, 32, 8, 2, and 1, which I can't get on this screen, that is going to give us 235. And that's it for our number conversions. Please let me know if you have any questions.